No, he's gonna face the wall.
Yeah.
He's already told us what he's gonna do. He's
That's
gonna sit
true.
right there and face the wall.
So you're gonna let
What?
Yeah. Jeremy doesn't wanna look at people, have them look at him. He's gonna sit there, face the wall, and give his talk to the wall.
I'll do that
You can borrow my mirrored shades.
We can accommodate you.
too.
What's that hardware on top there?
It's another phone. I'm on call.
Got it.
No days off. So I apologize if it rings while I'm giving my talk. Hopefully it doesn't.
I think you got it planned.
I don't know. I don't.
Sorry, you gotta go.
Sorry. Yeah. It's just okay. After 10 minutes. All right. Yeah, sorry, I gotta go.
Yeah. So Tayo, another 2 days, you can put your coat away again.
Yeah.
It's gonna be nice to sleep in tonight. Past 5 o'clock.
So you just tell me whenever?
Yeah, pretty much. Nope. I don't know. For the past couple of weeks, everything just seems to like fall in place to where I just never get a break.
Where do you work?
Where we had the 103 class in that building. And then for the exercise, I got volunteered for security forces. So I got to sit in the shack for 14 hours a day and check IDs. Yep.
I'm glad that didn't get old.
Got old after the first hour. They put you in a shack with a microwave and a chair.
Yeah, well, imagine doing that for your whole life.
Yeah, I couldn't.
Like some of those guard guys
Yeah.
do. And smile and say pleasant to everybody.
I got tased. That was
How was that?
fun.
What's tased?
Like a taser gun.
You actually got that? How'd it feel?
It wasn't fun. They do training, and they take volunteers just so cops know what it feels like, so
Sure.
they don't just go around shooting people
Yeah.
with tasers. So
Mm-hmm.
I was falling asleep. I think it was about 3:30 in the morning, and he was like, "Hey, let's go get you tased and wake you up." So I did it. What's that?
It worked.
Yeah, I was awake for about an hour, and then I started getting sleepy again.
What fraction of a dose they give you?
I don't know. It's just
Yeah,
whatever
right.
their standard is. Put you out for about 5 seconds, and then you just they
Mhm.
have somebody on each side holding you, and you just fall to the floor, and then
Your heart stops and all that? Hmm.
I don't know. I kind of wanted to do it just to say I've been tased before.
Oh, yeah.
Never do that again.
You put pepper spray too?
No, they try to get me to do that. I didn't. That's
I've done pepper spray.
I wouldn't do that.
It works. I mean, I got some because I had a neighborhood gang of kids that was annoying me.
Oh, man.
But before I used it on them, I wanted to use it myself, so I know what it would be like. So I dosed myself, and then I dunked my head under the filled up bathtub of water and kept it there for an hour, and the pain was pretty intense. And if you don't have that, I guess it's unbelievably intense.
Yeah.
It works.
Yeah.
I got to do the gas chamber in boot camp. That was good enough.
Gas
for me.
chamber with what gas?
Tear gas.
Tear gas, yeah. That's bad stuff too.
Yep. They make you. It's like so they put you in a room and you do jumping jacks and everything to get your heart racing, and then you take off your gas mask. You got to stand there for 15 seconds, and then they make you try and talk. You can't talk because you can't breathe, and then if you run, they open the door, and if you run out, they make you turn around and stand there for another 10 seconds. So you have to calmly walk out while you're inhaling tear gas. And, yeah,
You pulled it off?
I did.
I kind of liked it.
You liked
Yeah,
it?
as weird as that sounds.
I
Because like, once I got out, that was the best I could breathe in my entire life.
yeah, clears out your sinuses and
Clears
stuff. Yeah.
everything. So if you ever got
Aye.
sick, if they gave me a choice of like medicine or the gas chamber, I'd go into the gas chamber,
That's
get
interesting.
cleared out, and then be like.
How long's that
ready to
cleared
go.
out feeling last? A day or two?
Oh, well, I don't want to say, yeah, the rest of that day, at least.
And that's the way normal people feel. You finally experience that.
If you're not throwing up or crying or,
Yeah.
Well, all that side stuff, but clogged sinuses, I mean, if you have it chronically, you just don't know what normal people feel like. How come everyone's always smiling and laughing, huh?
Did you have to run after yours when you got done?
well, I couldn't breathe for about 5 to 10 seconds after I got out, and then they just make you walk around with your arms out and just constantly blinking to like try
Yeah.
to flush it out of your eyes.
Yeah, when I went through, after we got out, and after everybody got thrown up, done throwing up or whatever, we had our PT clothes, like our workout clothes, on underneath our chem gear. So they had us take off all the chem gear, and
Did
we
you run
ran
around?
back to base.
What, to clear your lungs? Or
Well,
just for
no,
cruelty?
just for exercise.
Yeah, I remember them making us run after we got our penicillin shot. That was
Oh,
probably
God,
the
yeah,
worst.
that would be bad.
Why'd they do that? What's the logic there?
Just cause.
Just cause,
Just torture.
Yeah.
Yeah, that wasn't fun. We had a
hmm,
50-pound rucksack and
penicillin shot, what do you get a penicillin shot for? I mean, that stuff's only temporary,
It's
it
the,
has a lifetime.
the government says it's okay. It's good, right?
Yeah, just
I think you're sardonic.
whole list of shots
Sarcastic.
maybe that day.
Yeah, I just saw one pop up on my list last week. There's like a Japanese encephalitis or something.
Oh.
Something. I guess there's mosquitoes in Japan that 1 in 5 people that get bitten by mosquitoes are dying.
Really?
Yeah.
What?
I've never had that one.
That's ridiculous.
It's like, yeah,
What?
1 in 5
Is that true?
It is. Yeah, they're making everybody get these Japanese encephalitis.
Well, how do they find out how many people got bitten by mosquitoes? I mean, that's a querulous statistic, I think.
I don't know. It's. Yeah,
What do you do, lie
statistics.
detector test? Have you been bitten by a mosquito?
Yeah, those are no fun either.
I think the worst bug bites I've had were from here, those
Oh, yeah,
big
this big.
flies, whatever those ones
Yeah.
are.
Yeah,
Right.
I'm allergic to bees, so.
Like
so-
anytime we ever did any workouts over here on
Right.
that
Yeah.
artificial turf,
Mm-hmm.
I always came home with these little, look like just mosquito bites or whatever, but they would just like
Then they get
break
welts,
out into
big
like
welts.
Yeah, welts and
Right.
sores.
Mine was so bad, and it was so strange to me, I went to the hospital, they said in the summertime, 80% of their emergency calls are these kind of bites,
Yeah.
bug bites. Masawa bug bites are top in the world.
Oh yeah.
Oh, yeah, they'll last a week or two, and they get that hard center.
Yeah, and they said, "Oh, your leg's not falling off. You're all right. You're good."
Well, yeah, but if it, you gotta come back if it gets worse.
Yeah. But I still have scars on my leg from those bug bites.
Yeah, and the bug's teeny, the one that does it.
Yeah,
I mean,
yeah.
he's just potent. Don't even see him sometime.
You're in the Air Force?
Yeah,
What
it's
was
8
your-
years.
8 years?
Yeah, and financial management. Yeah.
Nobody messes with payroll people. Send your records to Guam. Hi, Laura.
Yeah, I've had quite a few troubling times with finance.
Yeah. There are, just like any other business, there's
How
people that
doing?
are good at it over there, and there's people that aren't. You gotta find that one person and stick with them and make friends with them, and
When I got stationed in Texas, they overpaid me like $3,500. And I went into finance and I was like, look, you guys are giving me money that I'm not supposed to be getting. I was like, I don't want this money. Please take it out of my account. And they're like, no, that's your money. I talked to like, all the airmen and their supervisors and the commander and all that stuff. And they're like, no, that's your money. And 6 months later, it's like, hey, I'm a Padre, you owe us $3,000.
Yep, that's the Air Force.
so,
Yep.
Absolutely right.
Good thing I put in
Yeah.
this.
Yeah, good thing you set it aside.
But
that's too bad.
they're quick to take your money.
If they do it now, would you still say it's not your money, or you got a little hard feelings here?
Yeah, I would give it back. I've known people that have been getting overpaid for years, and they don't ever say anything, and then they get a call 5 or 6 years later. It's, hey, you owe us $40,000. It's just,
I was the person that did the debts and stuff.
yeah, that's insane.
And that's collectible,
Yeah.
even though it's their mistake?
The
I
Air
had
Force,
to-
the Air Force is gonna get their money one way or another if they overpay you.
I had to do a
Well, any
review of
military.
everybody on the entire base, their COLA, and if they were getting paid correctly. Yeah, there was a lot. There was I wanna say maybe 20 people were getting underpaid, so they ended up with huge payback checks depending on their rank and how many people there were, but there was also, I wanna say 150 people that were getting overpaid or.
Do, do officers get exempt from prosecution? I mean,
No.
if you catch them, they gotta cough up too?
Yeah,
Yeah,
everybody.
they probably won't get in as much trouble as the airmen will, but yeah.
I remember I went to Korea back in August for a couple weeks, and they paid me as if I had moved there for a
Yeah.
year. So they gave me like the dislocation allowance and all that
Yeah,
stuff. It was a hassle.
yeah.
So you're gonna do your 20 or 30, hey?
I want to try and finish my bachelor's before this semester.
Make that decision, yeah.
Yeah.
See what your weapons are.
I have some people in Texas.
Yeah, it's nice to get that TA to get a free degree, hey?
Yes, it is.
Some
Yeah.
people will take advantage of it, they just take as many courses as they can all at once, and
Wait for it to.
you know anybody like that?
Yeah. I don't know. There's people that never use their TA, so
Yeah.
Well, you use yours,
Yeah,
that's for sure.
Yeah. It's one of the reasons I joined the military. When they took
There's
that
such a
away.
thing as eating too many chocolates from the box, so you get a sick stomach.
I think it's good on you to do that, yeah.
So, as a time check, 9 minutes.
That's one thing I regretted, not doing it when I was like a lower ranking and like I had all that time and
Yeah,
then,
especially
Well, you got the GI Bill now, right?
oh yeah, it's,
Yeah,
I mean,
it's
way
gold.
better.
yeah.
Yeah, I'll take my $4,500 a year.
Yeah.
I don't know. It's just people that don't want to use it, don't want an education.
Yeah.
It's just,
No,
it's just like there's.
they already know everything, why they need education.
Yeah. Yeah, there was a guy here on base, I don't know if I'm allowed to, I probably shouldn't say any names or anything. Throw anybody under the bus or
You're looking
drop
for 'em.
names, but there was one gentleman that had been divorced for about 5 years. And he'd been collecting,
Hmm.
because if you have a spouse in the States, then you also get all your entitlements here, plus their housing or whatever, wherever they are in the States.
Ooh.
Well, he was, he didn't tell anybody and was pretty much lying that, because every time you move, and every once in a while,
You gotta sign it off again.
finance will, recertify.
Mm-hmm.
And so every time he lied and said he was still married to this lady in California or whatever,
That's jail time.
well, they caught up with it finally, and it was somewhere around $190,000.
Mm-hmm, mm-hmm.
And, but, well, you know what, I think it was more like 10 years, actually, but they could only take back,
They can only take back a certain amount. They can't take all your money.
I think they could only take back 3 years,
Wow.
or something.
Mm-hmm.
That's weird.
And the thing is, he'd been in for 20 years,
Aye, he's done.
and so
Mhm.
they actually, what they did is they took one stripe away. They took back I don't know, maybe $40,000
Mm-hmm.
and let him retire.
They let him retire?
That's ridiculous.
Well, he's smiling all the way to the bank.
So, and I told my supervision that I was really disgusted with the outcome, because basically what you're telling airmen is, you
Yeah,
can get away with lying and you're gonna
yeah,
get paid
right.
for it.
Well, he had friends.
Yeah.
He had friends.
I don't think it's about friends, it's the same thing in the Navy too, I think
Yeah.
it's a structure in the entire military. If you reach that 20-year mark,
Mm.
and you get capped on, there's certain, things that you can get away with compared to someone who's.
It's true. They're very forgiving, because they're gonna be there the next year themselves.
Yeah.
Because I know a senior
Yeah.
chief
Right.
on my last deployment, he actually, we just gave him deployment and we got called back within 3 months. We had just spent about 11 months on the boat, on ship, and then within 3 months, a call back for another 10 months. So he didn't want to go, he went and spoke he went and smoke. He got say that he wanted to go somewhere and smoke weed. And he knew he was gonna get popped, urinalysis. So just before we go, we went for a urine test, and he knew what he did. So and he already did about
believe this.
25 years.
What?
Senior chief. 25 years. So what it did, it just told you how to get, you gotta retire, plus another 20, take away 5 years, so 20 years entitlement.
That was intentional, just what he wanted.
Yeah, it was intentional.
Guy
But
plays the
he already
game,
knew- Yeah, he knew exactly what he was doing.
plays the game.
Yeah, it is a game.
Have you ever
Plays
been
the
in a
game.
station in Norfolk?
No.
No,
Oh,
my dad was there.
Okay, 4 minutes, so time to get nervous.
Where is everybody?
No, nobody else needs to come.
Kayla can't come, Karen
Oh, yeah,
probably is
Karen.
gonna show for a few moments. And Sean's in Hachinohe, he can't come either. This might be it.
That's the whole side of this.
Yeah, this is a whole flam-damly.
Yeah.
That's it. But I'm the important guy because I give you the grade. So even if it's only just you and me, then that's everybody.
All right,
Hi, Karen.
my sidekick.
Yeah, there you go. You're up first?
Yeah,
Hey, how about that?
I'm ready to go.
All right.
I'm ready to get it over with.
As a matter of fact, well, let me see what Iwakuni's doing.
Oh, yeah. We'll give you a chance.
I might not even have anybody come.
I want to use my timer, but at the same time, I don't. You know? I don't want to look at it, but I don't want to stop and be like, "That was 15," and he's like, "Oh,
No, don't be that
7."
crucial in the time. Don't interrupt your spirit. Hello, Iwakuni. Iwakuni, how's the sound? Can you hear? Oh, that's nice. So, Iwakuni, raise your hand if you can hear me. How's the volume? Is the volume okay? Should it be louder? Raise your hand if it should be louder. Oh.
Go ahead, sir.
I can hear you. Can you hear me?
Yes, sir. We hear you perfect, sir.
Okay, and I hear you perfect too. Thank you. We'll have our first talk up here, then we might have a talk down there. You're sitting in the right place for the talk.
Yes, sir.
So maybe other 2 more people to show. We'll give them another 3 minutes.
Yes, Professor, just a reminder, Mimi said she's going to be a little late.
That's right.
Yes, sir.
How about your other cohort?
No, in fact, no idea.
No idea. Okay, we'll give them clock time.
Thank you, sir.
Guy is so respectful. Marine. You guys ought to watch that.
I blame that last quiz on my lack of sleep. by the way.
Was it lack of sleep or you have too much, you spread too thin?
Probably.
Okay. Actually, that was a hard week. Everybody's score went down mostly on the hypothesis test. It's harder material. A few people stayed constant, but some people didn't. Just harder material. So let me know if you guys don't want to be videoed, because you have a right to a lawyer in a situation like that. If you don't want to be videoed, we will not video you. Okay, Paul's got what we call speaker anxiety, and he just went to the restroom.
Get a drink.
We know about those, urgencies just before you speak.
We need to move the mic to where, to the computer.
No, with the mic will handle fine from the computer. All you have to do is talk over your shoulder or something like that. Because that way you're on camera, and if you go to the computer, you're no longer on camera. So,
Oh, really?
yeah, so I think your audio will be fine. I think it'll be fine, just
I
keep.
can sit at the computer.
Yeah, you can sit at the computer when you need, you wanna run your slideshow from the beginning?
Well, yeah, and I have to press the space bar to, to show the next thing. that
Right.
I'm talking.
The only thing is, we have prior experience that whenever you touch the mic, then things go out. So,
Maybe I can sit with my back to you. Is that okay, or you got that camera though?
yeah, well, let's try sitting with your face to me.
Face to you. Okay.
I wouldn't do this for anyone else.
You be all right with looking at me for 15 minutes, Tom?
No, this is the camera, I'm gonna look at the wall.
No, can you hear me down there?
Just a second, I didn't give you the go-ahead yet.
Oh, I just want to.
You're not in
I
charge.
just want to know if you
You're
can
not
hear
in
me.
charge, guy, I mean,
Well, I just
turn
wanna
it
know.
Yes,
down.
you're perfect on it.
Okay, awesome. Thanks.
You're not supposed to answer 'em. Okay, we're set to go, so this will be our final session, and nothing else after this. Your grades in this course will be sent to you by personal email from myself with the grade in the course and the score on your last test, and on your talk, well, that'll all be in Leo, so you don't need to get it from me actually. So will your grade in the course be in Leo, so you may or may not get an email with me since we do have Leo. Probably not, so just keep checking Leo, it'll all be there. It's been a great course, so I'd like to thank everybody, because you guys made it successful. A lot of hard work done in here, and a lot of statistical learning taking place. So I thank everybody here. Okay, our first speaker is gonna be Paul. Paul, go.
All right. Let me get everything pulled up here for me.
First, we gotta see if the audio is working. I may have to move this because you tend not to talk too loud, true?
Oh, I can. If you want me to talk loud, I can talk loud.
Yeah, we do want you to talk loud. Okay?
Okay. All right. You good?
Go.
Okay. Hey, everybody. Welcome to my talk. It's going to be about Nate Silver. He's a famous author, statistician.
Keep
However
going.
you want to say it, tomato, tomato. And he also runs a famous online blog, the 358, as well. I know everybody hates PowerPoint, so I kind of hopefully made this a little entertaining for everybody, so you won't fall asleep. There's even going to be a video at the end. So there's a lovely picture of him. He's a little older than me, looks a little better than me too. But all right, anyway, so math. I'm sure a lot of you have heard in your life, or maybe you have even said, I don't need math at all. What's the point? I'm never gonna use this after my senior year in high school. When in actuality, everybody uses it on a day-to-day basis, whether you worked in finance or whether you are balancing your checkbook, or you gotta spend buy groceries and you only got $300. You gotta make sure everything balances out. So, anyway, we're gonna talk about Nate Silver. Like I said, he was born in 1978, and so he's a little older than me, like I said. But he has a bachelor's in economics from the University of Chicago, as well as going to school in London at the School of Economics. He later became known for his use in sabermetrics, and a lot of people, don't even know what the saber is, so I included that here. It's the Society for American Baseball Research. Now, with sabermetrics, it's basically figuring out the measure of a baseball player's skill. And when you think about that, you're like, okay, well, like RBIs, hits, and home runs. Well, not actually. What it goes and it's based off of is a player's offensive runs, or the ability to produce runs, versus an average player of the same position. So basically, like if you have another right fielder, how is he compared to the guy that's sitting on the bench that's just average, not the starter? Alright, so what does this have to do with Nate Silver? Well, he used this sabermetrics to create his, I'm not sure how you're supposed to pronounce this one either, PCOTA, and that stands for the Player Empirical Comparison and Optimization Test Algorithm, which is definitely statistics based. If you couldn't figure that out, it basically forecasts the performance of a player's production based off of subcategories that he used, like VORP and EQA. Now we're going to go over those as well here. VORP stands for the value of the replacement player. Just like I said before, like a batter or a pitcher versus the average player that's on the bench in that position. It's a cumulative stat or a counting stat, not projected. So basically what that means is if Jim Jones, I don't know, I just made up some name, has a VORP of 20 plus 25 runs after 81 games, he's contributed 25 more runs than the average player in his position over the course of 81 games.
Mhm.
However, like I said, it's cumulative stat, not counting, so as the rest of the season continues, his VORP could either increase or decrease. I don't know, he may fall and break his leg and he's stuck at 25 for the rest of the season. Who knows, he may take steroids and get up to 60 VORP or whatever. Then of course we have the EQA here. Now EQA stands for equivalent average. Basically it represents a hitter's productivity using the same scale as batting average. So if a hitter has a EQA of 300, he's a good hitter. 260 is average, and 220 or lower is poor. Usually, if you're talking about this for like a pitcher will, they usually don't have anywhere near the average for batting. And if you know anything about baseball, the American League uses designated hitters. But anyway, whole nother topic. So what's the equation for EQA? You may ask. Well, that's where the status or part of the statistics come into this talk here. So basically have the EQA, the equivalent average, equals this long equation here. So it looks kind of like the beginning of a stats problem, 200 problem, don't you agree? So
Yes.
what we got here is the H stands for the hits, the TB is total bases, and then we have that, and the 1.5 times the based on balls or walks, plus the hit by pitch. So if you get hit by a pitch, you get to go on base. That helps the EQA as well. Stolen bases, sacrifice hits, and sacrifice flies. And then that all divided by the at-bats, the base on balls again, the hit by pitch, the sacrifice hit, sacrifice fly, caught stealing, plus the stolen base divided by 3.
Mhm.
It's fairly advanced, kind of. Well, it's not really advanced. It's long drawn out process, which is why you can imagine that he uses a lot of computers and Excel or programs like that to do these sort of things versus doing everything by hand or using a calculator. So now we're gonna break out an example here with our ever famous Derek Jeter, who most of you may know from the New York Yankees. So we have the equation from the previous slide here. So if Derek Jeter in 2014 had the following stats, what would his EQA be? So if he has the hits and all these stats here, we're going to go through and figure out what that was. Now, can anybody, just by looking at those numbers, maybe predict whether he's going to be average or below or
287.
287?
All right.
Maybe any other guesses? Maybe.
What do you mean guess? It's a
Or
calculation.
theory, or
It's a calculation.
hypothesis. What do you think, Tom?
It's a calculation.
287. He's already done everything in his head. All right. Well,
You gave me the equation.
$20, Tom. We're gonna.
Gold.
No. All right. So we put all the numbers into the equation here, and we end up with 648, which is pretty astronomical for that's pretty huge, actually. So
Wow. I never
that's for
would-
2014.
I
So
never would have been.
who knows what his other years
Yeah.
looked like, but that's just an example there. So.
Wow.
Now, he's also known for his political status, or statistician part of his life too. His predictions, where just for example, in 2008, he got 49 of the 50 states correct, and I guess possibly most recently, in 2012, he got the Obama election 100% correct. How, you might ask? Well, he used a lot of source data, mostly national polls, and incorporating hundreds of state level polls, economic variables, demographics, and party registration figures. He used past data as well, which is what anybody should use when they're doing stats. Don't just base your statistic on, okay, well, today I think it's gonna snow in Misawa. Well, why? Well, for the last 3 years on this day it snowed in Misawa. So that's, everybody should use past data for that kind of thing. And he extracted info from every source. So unlike most of his, minor league colleagues, he took all the info into consideration versus just picking, one or two things that he liked, or going with the sorry, I'm looking for the wording here, the House effect, or what favored maybe the Republicans or the Democrats. He used all the data versus just the little things here. And then also the understanding of the correlation. He also understood that some of the political data was connected. For example, like if Texas moves in a right-hand direction, well, possibly Oklahoma will too.
Mm-hmm.
So that's another thing he had to take into account. So, everybody in this room, I'm sure after this talk, wants to know what the secret is and that they want to make money doing this. So, after hours of searching the internet and, hour-long YouTube videos, I didn't find the equation. I apologize. So, no one's going to leave here today and turn into Nate Silver. Sorry, Tom. All right. So
He's
much
my
for that.
son.
So the conclusion that I'm going to end up with here, minus the video, which is going to be afterwards, because I just wanted to show like how he talks and how intellectual he sounds, and I just wanted to share that with you as well. But with the conclusion, this may sound kind of odd, but Nate Silver versus Kanye. So if you think about it, like, we may just be doing simple statistics here in this class, or have, I guess you would say, but he's taking everything into consideration. So maybe his day-to-day thing is, well, if John Doe doesn't tie his shoe today, is he gonna trip and fall? And is he gonna make it to the polls? Well, what if someone has a family emergency and he's not gonna make it to the polls either? He's not gonna be able to vote, and that's gonna take everything into consideration. And what if Kanye rushes the stage, Tom? That's gonna ruin the whole show. So, I have that there. The picture of Nate Silver on Chuck Norris's head and Kanye West there. Alright, now we're gonna switch over to my video here so you can see, okay, what he sounds like in
I hope I
person
didn't
here.
turn Iwakuni off, but keep going.
No,
Yeah,
hopefully
go.
I just
Let's go.
tabbed over here, so
Mm-hmm.
we'll listen to
Okay, well, I guess
few
we
minutes
should
here.
get started. My task is to introduce our speaker. Now, I suppose it's theoretically possible that everybody just wandered into this room by chance, expecting that something interesting might be happening. I don't know, what do you think, Nate? Is that plausible?
You could have herding, right? A few people actually know what they're doing, and everyone else kind of follows along. And
Yeah. It could be, but I'm guessing that event has a relatively low probability, so I'm guessing that most of the people know who our speaker is, and you know his story, so I'm not going to introduce him, I'm just going to turn you over to Nate.
That's the Mickey right now, the signal and the noise.
Well, thank you. I'll spare you the kind of wedding toast speech, and we'll get to the questions pretty soon. But it's a real honor to be here at Google. In my view, probably the smartest company in the world right now about working with data and using it to actually transform people's lives. And I hope that some of what we were able to accomplish, and I tend to use we when I mean I sometimes, right? But I do see it as kind of a collective project that 538 is a part of to make journalism
That's
smarter,
his website,
to make political coverage better, and to just have people be a little bit more more data literate and data savvy. And when that kind of hits into the punditry, then interesting things, I guess, can happen sometimes. But we have a lot of great questions, it looks like, and I think we'll leave time. There'll be time for questions at the end from people in the room as well. So let's get started.
Absolutely. So we produced all these questions using Dory, so these are questions submitted by members of the audience. The techniques in 538's methodology section were invented ages ago. Someone could have done what you were doing, but at least in the 1990s or earlier. Why did it take the world so long to produce and appreciate Nate Silver?
I'll end it after this.
I was busy playing poker,
answer.
yeah.
It's aside your mom.
My mom, right? No, if you know, if the Congress hadn't basically banned internet poker, then maybe I'd still be doing that, right? No, so in all seriousness though, it's only been a few election cycles, maybe the last 4 or 5, where you had as many state polls as we do right now, and it's only been more recent than that we can really collect them pretty easily on the internet, where you do a Google News search, or you steal from Real Clear Politics, or whatever else, right? But collecting all that data and have it be essentially free isn't something that's been able to be true for all that long, really. But also I think people are taking more of a do-it-yourself mentality toward aggregation and toward producing content. When a news organization, and the Times is no exception, produces a poll, they want you to think it's the only poll in the world, right? They don't provide the context of, well, this poll says that Romney's ahead, but the other 12 polls say he's not, right? Which is what a reporter probably should do, but so you have, I think, some perverse incentives in news organizations who produce their own polls, which are expensive, and I'm a fan of good, expensive telephone polling, to pretend that no one else is doing the same thing, right? And so I think that's part of it. It kind of cuts against the
Next
newsroom's
question.
first instinct, and part of it is that, you know, this is actually a relatively new thing where you have so much data available for free.
So right before the election, the Romney campaign claimed to be confident that they would win. What was wrong?
Okay.
Give
Yeah,
them
sorry,
the-
I just wanted to include,
Yeah.
just a little bit of him live, because,
Why don't you run this another couple of minutes, because this is a highlight, the Romney campaign and the Obama election. That was what made him who he is.
Okay, you
So
want
go
me to
ahead
let it
over,
go?
just run
Okay.
it a few more
With their
minutes.
internal polling. Why were the predictions so far off? Or were they just keeping a straight face when they knew that defeat was coming?
Yeah, I think maybe more, well, there are different layers of the Romney organization, right? And one question is what did Mitt Romney himself believe? And, you know, I'm not sure about that. There's a question of what did Mitt Romney's pollsters really believe? And, you know, it's probably not what they told the press exactly, right? So I think there's some culpability here where the press is fed spin and bullshit, basically, right? And then they act surprised later on when the bullshit, in fact, turns out to be bullshit, right? And they, and they blame the messenger when they should be blaming themselves. But, you know, when campaign pollsters talk to the press, they're not trying to produce accurate information, right? They're trying to put things in the most favorable light they can. You know, I had very few conversations with the campaigns. I try and avoid that, almost go out of my way to avoid that. But when I talk to the Romney folks, they tended to have a pretty realistic view of what the landscape looked like. Maybe it's because when they're talking to me, then I'm not going to go actually report that. It's just kind of a friendly on-background conversation, so maybe you get less spin and a little bit more actual insight. But, you know, I think, you know, it's not hard to tell. It's hard for a campaign to operate under the assumption it's probably going to lose, right? Then it seems like it's wasting its time, and so there are all kinds of different biases that can creep in, from confirmation bias in the way you kind of construct your samples to what news actually gets reported to the candidate. I think any organization, whether it's a political campaign or anything else, if you're an organization that can do a reasonably good, a reasonably honest self-assessment, that's a big edge. That's why, by the way, consultants make millions of dollars per year, right? McKinsey or whatever else, right? They're not really adding a lot of value necessarily. I'm sure they're very smart people, right? But with the actual work product, so much as they provide mediation services to resolve internal conflicts in companies, right? Where you can do politically incorrect things if you hire McKinsey to go in and say something obvious, basically, right? So it's kind of the same agency problem you have, I think, in a political campaign where, and by the way, one thing the Obama campaign did in a way, I'm not sure about this year, is they had 4 or 5 different pollsters that worked independently from one another, at least to some degree. So they would have maybe the same two different pollsters in-house survey Ohio. And then if you have a difference of opinion in one candidate, one pollster might show a tie in Ohio, one might have Obama up 5, then you can start to iron that out, and those discussions are often productive. But within a campaign, it can become something quite insular. I think in general, people overrate the value of the campaign's internal polls, right? Even if you actually saw the real internal polls, which you don't, right? Even then, I think, even though some of the pollsters are very smart, they're operating under worse incentives than you have for a public pollster, and you know, it's hard to add value relative to simple methods, right? With the extra things you might do, and so if you have bad incentives, then often that that leads to worse overall results, even if you're a more capable person in some abstract sense.
Okay, we could cut that. That was a
Yeah.
good explanation. Okay, I think we just had a fantastic talk, very high marks, very well researched, very well organized, very well balanced, very relaxed human speaking voice. He didn't do any reading. He knew his stuff and he just talked. And he came across, he communicated, we absorbed stuff from him, and the information on it is very good. The introduction was quite weak. It took a while to get started, didn't really tell us why Nate Silver was important. We dug it out near the end. We forgive him that, so he got a very good grade on it, and I think you'd pat yourself on the back as you trip back to your seat.
Thanks.
So let's minimize that. Yeah, Okay.
Minimize it.
yeah, and leave it here. Minimize this one too. This is your PowerPoint, I think.
Escape.
Okay. And now, okay, so let me,
Oh, yeah. You know how to eject that?
pardon me? Oh, let's do that later.
Okay, yeah.
If we touch it, it breaks. Iwakuni, can you hear? Okay, I apologize if that didn't get shared right or come across. We had to go with it without correcting any malfunctions. So if you didn't get a chance to see that, I'm sorry that that happened.
Sir, it came across great. We were able to see and hear.
Okay, then you saw a very good speech. Now, would someone from Iwakuni like to go second? We have a person here that's hot to go if you guys want to wait a little while. Okay. Here comes Jeremy. Okay, now we need a little bit of volume and gusto. Iwakuni's pretty far away. So take 10 deep breaths, relax, and then start at your own time.
Okay, I did my report on William Gossett. He was born in Canterbury, England on 13 June 1876. He was the son of Agnes Vidal and Colonel Frederick Gossett. He was the oldest of 5 children. It was said before he studied mathematics that he wanted to become an engineer, but he was rejected for having poor eyesight. He was actually never employed as an official statistician. He's known as one of the most prominent statisticians in history. We know him for the discovery of the t-distribution and t-test. He had a profound effect on the practice of statistics in industry and agriculture. And a fun fact, a lot of people don't know him by his real name. They know him by the name in which he published his works, which was Student. He attended Oxford University and got a degree in mathematics in 1897, followed by a degree in chemistry 2 years after. In 1899, he went to work as a brewer and chemist at Arthur Guinness Son & Co. in Dublin, Ireland. The brewery was interested in hiring someone that could help them find out how they could produce better beer. This job led him to examine the relationship between the raw materials for beer and the finished product, which naturally led him to learn the tools of statistical analysis. His experimentation with hops was influential with his discoveries. He noticed that this brewery needed a more accurate statistical analysis for a variety of processes to include barley productions, yeast fermentation, and selection of best yielding barley varieties. He worked under the supervision of the Irish Department of Agriculture. His knowledge and advice on these matters was held high in regard, and he corresponded extensively with many other experimentalists. It can be said that Gossett did a considerable amount of pioneering work in the areas of analysis, invariance, and experimental design. He realized replacing the standard deviation with the sample standard deviation didn't produce accurate results when trying to calculate a confidence interval, which helped him realize that he couldn't use a normal distribution for his calculations, and the distribution depends on the sample size. In 1904, he drew up his first report titled The Application of the Law of Error. This report emphasized the importance of the theory of probability in setting an exact value on the results of our experiments, many of which lead to results which are probable but not certain. In 1905, he sought out advice of Carl Pearson, who was an English mathematician and biometrician. He spent a year at Pearson's laboratory at the University College London, and while he was there, he worked on small statistical problems, and he also worked on the Poisson limit to the binomial and the sampling distribution of the mean, standard deviation, and correlation coefficient. In 1908, at 32 years old, Gosset published another pair of papers titled The Probable Error of a Mean in Biometria. This was a peer-reviewed scientific journal published by Oxford University Press. He published these papers under the name Student, and there's a few rumors of why he actually used the name Student. One of them being that there was another researcher at Guinness who had leaked papers containing trade secrets of the Guinness brewery, and to prevent further disclosure of the confidential information, the company prohibited its employees from publishing any papers regardless of what it was about. The first half of these published papers dealt with a study dealing with the t-distribution, and the other half dealt with the small sample distribution of Pearson's correlation coefficient. This established that the sampling distribution of S squared and S for an independent and identically distributed sample size n from a normal population. And it also showed that the mean and the standard deviation of such sample are uncorrelated and derive what we know as a t-distribution. It was this paper's works that kind of placed them among the great statisticians of his time. An important aspect of his published works was that Gosset used a sampling experiment to help empirically solve the problem at hand instead of finding an arithmetic solution. He did an experiment at a jail where he took the height of the left middle finger of 3,000 criminals. He generated 750 random samples with a sample size of 4. He calculated the means, standard deviations, and correlation coefficients of each sample. He plotted the distributions of the samples that he gathered and noticed that the distribution is approximately normal and gave a satisfactory measure of the certainty to be derived from a small sample. Furthermore, he established that if the distribution is not normal, the mean and standard deviation of the sample will be positively correlated. The t-distribution is a continuous probability distribution that emerges when the mean of a normally distributed population is known and the sample size is very small. Like normal distributions, as you guys probably know, t-distributions have a bell-shaped curve but have heavier tails. Because it has heavier tails, they're more prone to producing values that lay farther from the mean. The t-test is used for assessing the statistical significance of the difference between two mean samples, the construction of confidence intervals, for the difference between two population means, and a linear regression analysis. The t-test is based on his works. The probable error of the mean in 1908 is probably the most widely used statistical tool that we use in statistics today. Some common uses for the t-test are in a one-sample location test of whether the mean of a normally distributed population has a value specified in a null hypothesis, and to test whether the slope of a regression line differs significantly from 0. At the time, Gosset's publications weren't really fully recognized as what they actually were. Many people of his time kind of based their studies on large sample size, while Gosset mainly focused on the smaller sample size. It wasn't until an English statistician named F.A. Fisher, when he generalized the t-distribution, that it was actually used outside of the Guinness brewery. F.A. Fisher was a student at Cambridge in 1912 when he first went to Gosset with proof of the frequency distribution of the Z statistic. Fisher's correspondence with Gosset began when Fisher sent Gosset a copy of his research applying the likelihood to estimate the mean and variance of a normal population. They wrote letters back and forth, and it was a couple of years until they actually met in person, and they met in August of 1922. They both admired the works of each other and kind of based their studies and developments of their ideas on one another. In the later years, Gosset and Fisher had a number of public disagreements over the role of randomization and experimentation. Gosset was a strong advocate of experimental control. He was enamored by the use of systematic experimental plans and opposed the use of randomization. In 1909, he published another paper titled The Probable Error of the Correlation Coefficient. This dealt with the distribution of the means of samples not drawn at random. His experience at Guinness drew his attention to the fact that successive observations were not uncorrelated. Around this time period, Gosset studied another subject that kind of grabbed his interest, him and Fisher, which was a theory of evolution. Many geneticists came to believe that hereditary traits are conditioned by a limited number of genes, and that selection involving a limited number of genes cannot lead to important evolutionary effects. Of course, Gosset and Fisher didn't believe this mutation theory, and in 1932, Gosset did some research and felt that there was evidence of a large number of genes at work, and that by natural selection, important evolutionary changes could take place. Using these works published by these geneticists, Gosset wrote two papers that supported the theory of natural selection. They were titled Evolution by Selection and the Implication of Winter's Selection Experiment. In 1935, Gosset became the chief brewer at the newly established Guinness Brewery in London. And on 16 October 1937, he died in Beaconsfield, England at the age of 61, still under the employ of Guinness. He will always be remembered for his research and discoveries with the tea distribution and tea test. Thank you.
So, our second outstanding talk, 2 of 2 so far, so it's going to be tough to follow that. The bar has been raised. This was a talk that was outstanding in a different way, and that is it gave such a solid, thorough, and complete statistical background and named the contributions of this person. This talk was exceedingly well researched. It was also very well delivered. As Jeremy mentioned under his breath on the way out, he did start talking a little fast, but that only lasted for a minute or two. Then he slowed down and he was quite relaxed, communicated very well. Of course, as he knows, he had to spend a lot of time reading because he had so much factual information. That's somewhat forgivable. He's just under time pressures. We know that. So I really feel that I know an awful lot more about Gosset than I ever would have known without that talk. And he was very well humanized when he went into his story with Fisher and that personal relationship. That was a very good human touch to it. And also the fact that he got into Darwinian evolution, which I hadn't known at all myself also. So another good, very good talk, okay? Okay, so now, Iwakuni, has your courage risen any? Do we have an Iwakuni person? It's your turn. Who's up? Jamie, Jeff, would one of you like to go? Okay, thank you, sir. Okay, you can set it up. Good job, Jeremy. Good job, Paul.
Thanks. They didn't call me in time.
They missed it. Good thing they didn't call you. You brought it off. Notice how different the two talks was. This is,
Yeah.
different content.
Yours is
So-
definitely more factual and,
Right, but that's the nature of the talk. You've got to speak to the strength of your subject, and both of you did. You had a personality, a modern day phenomena, and here we have a historical legend. So
Yeah.
they have to be presented differently to do it well. Yours wouldn't have worked good as factual information.
no, it
His
would've been boring.
wouldn't have worked well as
I don't, yeah.
as a personality. We needed it done the way they were done, both of them.
Yeah, mine definitely doesn't have like the factual,
No, he's
like
not old enough to be a
historical.
legend, he's still
Yeah.
alive.
Yeah.
So that you
I
can't
think
do
it's
that.
just, I think it's crazy that he just had a bachelor's, that's it, like,
Education kills creativity,
yeah, I don't know, yeah.
stifles. Okay, so Iwakuni's getting it together now, and we don't have real time pressure tonight, so
Yeah.
we can give him that slack. How many different sources did you work with, Jeremy?
A lot.
A lot,
Maybe,
yeah. Could tell.
Yeah, I've been stressed out.
Do you know his cause of death at age 61?
I actually couldn't find that.
Mm-hmm.
I know he got in a car accident that put him in the hospital for 3 months, but he only ended up getting a limp after that. It didn't really cause any serious damage.
Mm-hmm.
Drinking all
Yeah,
the
one thing I noticed in both talks is that your opening thrust was you named the year he was born, or how many children he had, or where his place and his siblings were. What you want to do when you open is you want to say why we're talking about Gossett, why we're talking about Nut Silver. Give us the importance of the person as your lead-in. That should
Professor,
be.
can you hear me?
Yes, we can lead you, or hear you. Are you set to go?
Okay, sir, so the audio is good?
Okay, so it's yours, go.
Okay, sir. One of the most inspiring teachers of his time, considered by most. Good afternoon, class, professor. My name is Jamie. I'm a United States Marine stationed in Iwakuni, Japan. The next presentation is going to be on Carl Pearson. So without further ado, Carl Pearson was born on 27 March 1857 in London. His father was William Pearson,
Why?
and his mother was Fanny Smith. Pearson's mother came from a family of master mariners who sailed their own ships from Hull. His father, William, came from Cranby, Northridge, and was a successful lawyer from Edinburgh, who eventually became a successful barrister and Queen's Counsel. In 1863, his family moved to Northwick. He and his brother Arthur attended a small school that had 15 pupils. The school was established by William Penn, who also provided a home tuition for Carl in 1866. Later in 1866, the family moved to Mockingbird Square, Bloomsbury, which he lived until he was 16 years of age. Both of his parents, William and Fanny, wanted both their sons to attend Cambridge and expected at least one of them to read in mathematics. Arthur received a scholarship to read classics at Cambridge. Therefore, it was left to Carl to study mathematics. At age 15, Carl's father, William, began to look for a good Cambridge wrangler to prepare him for the mathematics triphos examination. His father, William, always thought Carl was destined for a distinguished career, so his search for a wrangler was highly motivated. In 1874, at Merton Hall, Cambridge, Carl began to be coached in mathematics by several tutors, including the great mathematics tutor John Edward Rode. John Edward Rode introduced Carl to the mathematical theory of elasticity, beginning their long tutor sessions at 7 a.m. every day. In 1857, at 19 years of age, he was accepted to King's College. During this time, Carl found the demanding requirements of mathematics to be the tonic that he was looking for. You see, growing up, Carl was ill. He was an ill, weak boy who seemed to be somewhat depressed all the time. In addition to studying, the students were expected to conduct regular exercise as a means of preserving a robust constitution and regulating their workday. Some of Carl's favorite activities included walking, ice skating, ice hockey, and tennis. In addition, he enjoyed lifting weights and playing billiards. As a diversion from mathematics, Pearson began reading romantic novels. These novels he read inspired him to write his first book, which was, as a surprise, a romantic novel. The book's called The Norther. Later on, in 1879, Carl graduated with honors. He subsequently received a fellowship from King's, which gave him financial independence for about 7 years. Following his fellowship, Pearson began to make his way to Germany, pursuing other activities that interest him. Having already considered the possibility of becoming an elastician, Pearson began spending 3 to 4 hours a day in the engineer workshop, while also studying medieval languages and reading philosophy, with hopes of one day becoming himself a philosopher. However, he found that being a philosopher would make him somewhat miserable. He then started studying physics and metaphysics. At this point in his life, he began a quest to look for the truth, which even tempted him to becoming a Roman Catholic. His quest for the truth, which was paramount importance to a Cambridge-trained mathematician, became a template for the work he pursued and ultimately shaped the direction of his career. By the age of 24, it seemed that he would follow his father's passion of law, but he was tempted by many other possible careers. In 1984, Pearson was appointed professor of applied mathematics and mechanics at University College, London. He taught graphical methods mainly to engineer students, and this work formed the basics for his original interest in statistics. In 1992, he published The Grammar of Science, in which he argued that scientific method is essentially descriptive rather than explanatory. Soon thereafter, he began emphasizing the importance of quantification for biology, medicine, as well as social science. It was a problem of measuring the effects of natural selection brought to him by his colleague, Walter F.R. Weldon, that captivated Pearson and turned statistics into his personal scientific mission. Pearson was intensely devoted to the development of mathematical theory of evolution and became an acerbic advocate for eugenics. Pearson played a leading role in the creation of modern statistics. The basis for his statistical mathematics came from a long tradition of work in the method of least squares approximation. The least squares approximation is a method for estimating the true value of some quantity based on a consideration of errors in observations or measurements. This theory worked out early in the 19th century in order to estimate quantities from repeated astronomical and geodetic measures using the probability theory, a mathematical tool used to study randomness, which deals with the chance or likelihood an event would happen. Through his work, Pearson also is responsible for considerably further developing the idea of correlation. This theory, developed in the early 1900s, gives the strength of association between two variables. This theory should also be pretty familiar to the class since it was in last night's quiz. The distribution, first discovered by the German statistician Friedrich Helmert in 1875 and rediscovered by Karl Pearson in 1900 by developing the Pearson's chi-squared test. The chi-squared distribution is the distribution of the sum of squared standard normal deviates. The degrees of freedom of this distribution is equal to the number of standard normal deviates being summed. And in the formula, we can read as x squared is equal to the sum of the frequencies observed, subtract the frequencies expected, divided by the frequencies expected.
Good.
The top portion, the numerator is squared. The chi-squared goodness of fit test represented what some consider Pearson's single most important contribution to the modern theory of statistics, for it's raised substantially the practice of mathematical statistics. The significance of the chi-squared distribution and its goodness of fit test meant that statisticians could use statistical methods that did not depend on the normal distribution to interpret their findings. Through his studies and Pearson's conquest for the truth drove him to write papers and books on elasticity, engineering, mechanics, philosophy, and physics, where mathematical statistics was to become another means to that truth. In a period of about 28 years, Pearson founded 7 new academic journals. Biometrica is the most known and most prestigious statistic journal today. Throughout his life, Pearson published more than 650 papers or books. 400 of those are statistical. The main set of his collected papers consists of 235 boxes containing scientific manuscripts and more than 20,000 letters deposited at the University College of London. The work he published was read by many. As a 23-year-old, Albert Einstein created a study group with 2 younger friends, stating the first book they each must read was The Grammar of Science, a book written by Karl Pearson. Other Pearson contributions include the principal component analysis, which is the method of fitting a linear subspace to multivariate data by minimizing the chi distance. Another contribution was Pearson's systems of continued curves, a system of continued univariate probability distributions that came to form the basis of the now conventional continuous probability distributions. There are too many contributions that Karl Pearson contributed throughout his lifetime. It would be impossible to identify all of them in this 15-minute block. Karl Pearson was married to Maria. Maria Pearson, they had 3 children, Egon, Helga, and Sigrid. Karl Pearson's vision gave scientists a set of quantitative tools to conduct research. He was a Renaissance scientist in Victorian London. He was prodigious and consummate literary polymathy whose quest for physiological, spiritual, and numerical truth was his lifelong odyssey. I'd like to, before I close up, I would like to read a very famous quote from Karl Pearson. The classification of facts, the recognition of their sequence, and the relative significance is a function of science. and the habit of forming a judgment upon these facts unbiased by personal feeling is a characteristic of what may be termed the scientific frame of mind. Howard Pearson passed away in 1936. He was 79 years old. Thank you for your time.
So, another outstanding talk, 3 out of 3. How much longer can we keep this up? That was fantastic, Jeremy. You told me so much more about Carl Pearson. Jamie,
Yes, sir.
you told me so much more about Carl Pearson than I ever dreamed actually happened. The breadth of disciplines that he worked across, and you spoke very clearly, well-paced, and we could follow every single word and thought that you had. Your delivery was fantastic and excellent. Your research was very rich and outstanding. You gathered an awful lot of material and you communicated it all to us. So I feel very, very much enlightened by what you just did. So I thank you very much, and a very, very excellent talk. So
Thank you, Professor.
that makes 3 out of 3. Okay, so it's time for Iwakuni again. We need one of our 3 not yet spokens to speak. Who goes? Okay, Tayo is coming.
Okay, so my presentation is on John Tukey, one of the most influential statisticians, amongst other things. He was born in 1950 and died in 2000 at the age of 85. He made great contributions to statistics, science, government, and industry. His ventures outside of the academy, including working as a consultant to the government and corporations and taking part in social debates. He worked for the U.S. government during World War II. Friends said he did not speak on the details of his projects, but it's rumored he helped design the U-2 spy plane. After the war, he returned to Princeton, dividing his time between the university and AT&T Bell Laboratories, developing a wide range of revolutionary technologies at the time, which included the laser, radio astronomy, and the transistor. He coined the term bit, an abbreviation of binary digit, that described the ones and zeros that computers programs are based off of today. 3 decades before the founding of Microsoft, Tukey saw that software, as he liked to call it,